This is called transformations of quadratics. First thing I want you to do, at the top of your paper, I want you to write changing the a value in y equals ax squared plus bx plus c. Okay. The first problem that we're going to do, it says draw the table and graph for y equals x squared, the parent function. So what we're going to do is we're going to, off to the side, draw yourself right on there, y equals x squared. And you're going to draw a table there. And we're going to put points that will fit on our graph. Okay, so if it gets bigger than like 10 or 15, we don't really want to put those on there. So go to your calculator, put in y equals x squared, and get your table. Okay, so just to help you out a little bit on our table, when we're drawing, a good table for us to draw is starting at x value. What do you want to start at? Negative numbers. We're doing the whole graph. Probably -3. If we use -4, the y value is what? 16, and that's kind of too big. So we want to start at -3. The y value is -2, 4, -1, 1, 0, 1, 2, and 3. Those are good points to have on your graph. So use those points to create your graph. Okay, so does everybody's graph look like this? The parent function?
It looks just like that, yes.
Sorry. There we go. Okay, does it look like that? Okay, good. So now I want you to grab another color. Okay, get another color. Here's the next equation I want you to graph. So you want it on the side, draw your table, put y equals -x squared, get your table, and then graph. All right. Does your -x squared graph look like mine?
Yes.
Good, it should. All right. Now, if this problem, the original was y equals x squared, and the new one down here in green was y equals -x squared, right? So we have these two equations. What's the only difference? One's negative, right? So that's the only thing that changed. And when that happened, what happened to my graph? It flipped, right? It actually flips across my x-axis. So the first little note we want to make on our paper is when you change the sign of the a value, your graph will flip across the x-axis. Okay. Yes. Off to the side, right off to the side. So that's our first thing. So we had a 1 and a -1. Number was the same, sign was different, right? Same graph. Is it the same wideness? Yeah. It didn't get wider or more narrow, right? It's the same graph, it's just been flipped. So the next one I want you to table and graph is y equals 1/2 x squared. Get you a new color and graph this on that same graph. Okay, here's mine. Does everybody's look like mine? Mine's the pink one. Yes? Okay, so I want us to think about this now. We've seen this before this year. We've had the equation y equals 0. What did that look like? Y equals 0. What is that? Straight line, but what does it look like? Left to right. It's horizontal, right? And it's at where y is 0, right? So right now it would be on top of the x-axis, correct? Right? So if this is y equals 0, could I say this is the same as y equals 0 times x squared? That would still be 0, right? Except for this is not quadratic, it's linear, right? Okay, so let's pretend the number here in front of x squared was 0. If this was y equals 1x squared, our parent, this was y equals 1/2 x squared, and this one's y equals 0 x squared. You see that? Just given those three things, is there anything that you can assume? What's making it get wider? What's making it get wider? What's happening with those numbers that's making it get wider? It's decreasing, right? That number is getting closer to 0. So let's make a little note. The closer the A value gets to 0, so the closer it gets to 0, the wider the graph gets. And what would be the opposite of that statement? The larger the number gets. The larger the number, well, let's not put a number, let's put the larger the A value gets. The more what? Not that's well, steeps. Okay, let's use narrow. The more narrow. Let's say the larger the A value gets, the more narrow the graph gets. Okay, so when we're just looking at the A value, so we've talked about this. The closer it gets to 0, the more wide. The bigger the number gets, the more narrow. And if we go from positive to negative, it's going to flip over the x-axis. Okay, so it's the same exact graph, it's just been flipped across the x-axis. Does everybody see what I'm talking about? Okay, so on this next one, I don't want anybody to have a pencil in their hand. I'm giving you y equals 3x squared. I don't want calculators in your hand either. What is this going to look like compared to the parent function? Is it going to be going the same direction? Yes, it's going to go the same direction. It's going to be what? Steeper, more narrow. It's going to be more narrow. Okay? So I want you to come up with a table now, get a new color, and then see if what we were saying is correct. Alright, so this is what our graph should look like. So my 3x squared is here in red. Was it everything that we said it would be? Was it facing the same direction? Yeah. Was it more narrow? Yeah. Okay, everybody good on what A does? Okay, flip your paper over. On the back at the top, just like we did on the front, we're going to put changing, but we're going to put changing the C value. And then I want you to draw a big graph. Okay, first one I want you to put up there is the parent function again. So go ahead and graph that on your graph. Alright, so parent function, everybody's looks like mine? Yes? Perfect. Okay, so the next one I want you to graph is y equals x squared plus 2. Make sure you're using a new color. Make your table and graph. Okay, so this is the graph I got. Is that what y'all got? Yes. Okay, so what I want us to look at real quick, I'm going to put some points on here. Where it's running through my corners. Y'all should have these points on yours anyways, though, right? Okay, so when we're looking at these points, does anybody see anything? Yes.
All the points on the second graph are 2 units higher.
Good. All the new ones are 2 units higher. Higher. Okay? So, why do you think that is? Because there's plus 2. Now, did that make the graph wider or more narrow? No, it's the same exact graph. It's been moved up. Okay, we talked about how the A value made it wider and narrower, right? Okay. Well, if this blue one is my y equals x squared plus 2, and the black one is my y equals x squared, what could I say there? Plus 0. When I look at my C value, the 0 and the 2, the y-axis, good. So, what exactly are they? Besides just moving it up and down the y-axis, what specifically are they? They're the what? Look here. The C value is your y-intercept. If it's 2, your C is 2, your y-intercept is going to be 2. So let's make that note. Our C value is the y-intercept. Okay, so on this next one, before we even graph it, if it's x squared minus 4, I'm just going to start at where?
0,
0, not 4. Oops. Negative 4, good. So somewhere in our table we should have 0, negative 4, right? Okay, go get your table and then graph it. Go get your table and then graph. All right. So does everybody's look like mine? Well, let's get it here.
Yes.
Yes. So our red one here is our -4. Okay, now what do you think would happen? This is just kind of random. What do you think would happen if I gave you -x² -4? Yeah. Okay. Look. Intercept would still be -4, right? But it would be flipped. Good. Does that make sense? Everybody good on that? Okay, good.